Okay, now we're going to look at the growth of bacteria in a culture, that rate of change. And the rate of change, we got a couple of things. T is hours here, time is in hours, but the bacteria is in millions of bacteria. So as the time goes on, this is how many millions of bacteria there are. So how many bacteria were there culture when the bacteria was introduced? You have to know when it's introduced, that's in the beginning, and that's when in the beginning time was zero. In the beginning time was zero. And you put a zero in there, and what do you get? You get 1,000 million. If you put a zero into the original form, you get 1,000 million bacteria times zero. That wasn't very hard. You just have to know what the words are about. Let's look at the second question. Calculate the rate. The rate, that means take a derivative. We have to find a rate of change of the number of bacteria with respect to the time in hours. So all we do is take that formula and take the derivative. 50 minus 10t, but they said 3 hours. So they want to know exactly what's happening when t is 3. So you put 3 in. 50 minus 30 is 20, so it's increasing at 20 million bacteria every hour. That's the rate. And they ask about the rate of change, so you have to say, is it positive or negative? So it's plus, it's positive. If it's negative, it'd be decreasing at 20 meters per second squared. Okay, let's look at the next question. When does the population of bacteria begin to decrease? Well, I think if we need to know when we have to know it's been increasing. If we need to know the turning point to know when it's increasing and then zero and then decreasing. So b of t, the derivative is less than zero. Oh, it's decreasing. That's true. That's better to say it like that. If we get the turning point, which is 5, then to the right of the turning point, what's greater than, it's actually better to set it up like this. When is it negative? When is it less than 0? So it's 50 minus 10t, there's your derivative, is less than 0. So you subtract negative 50, and then you divide by negative 10, and you get t is greater than 5. And that makes a lot of sense because it was increasing before 5. It has to be decreasing greater than 5 after 5 hours. So there you go. Now the last question is, when will the whole culture of bacteria be exterminated? Oh, that means when will b of t equal 0? When will there be nothing left of the bacteria? So you just put the original population, when will it go to 0? You make it equal to 0, then you divide everything by 5, negative 5, to make it easier to work with, t squared minus 10t minus 200, then t times t gives you the t squared. 20 times 10 is pretty easy for 200. It must be minus 20 plus 10. So it's t equals 20 hours, because negative 10 hours, well, it doesn't make sense in this question. So there you go. There's the bacteria rate of bacteria growth question.